day, my dear students. In our video lesson today, we are going to discuss about sampling distribution of the sample mean for normal population when the variance is unknown or finite population. Expectation. The learning objectives are, at the end of the learning episode, you are expected to 1. Find the mean and variance of the sampling distribution of the sample mean, and 2. Define the sampling distribution of the sample mean for normal population when the variance is unknown. Before we begin with the lesson, let us have first a pretest. True or false? Write true if the statement is correct and false if the statement is incorrect. 1. Sampling error and sampling size are directly related. The answer is false. 2. Standard error is influenced by sample variance. The answer is false. 3. A finite population is one that consists of fixed number of elements. The answer is true. 4. When the population is large and the sample size is small, the correction factor is not used. True. 5. A population consists of the numbers 2, 3, 4, 5, and 8. The number of possible samples of size 3 is 12. The answer is false. Okay, let us recall, for our recap, let us recall finding the mean and variance of discrete probability distribution given the number of cars sold X and its corresponding probability P of X. Let us now fill up the column for X times P of X. 1 times 0.1 is 0.1, 2 times 0.3 is 0.6, 3 times 0.2 is 0.6, 4 times 0.4 is 1.6, and then let us add all of this. The answer is 2.9. Next is to square the value of X. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Then for the last column, we will multiply X squared by its corresponding P of X. 1 times 0.1 is 0.1, 4 times 0.3 is 1.2, 9 times 0.2 is 1.8, 16 times 0.4 is 6.4. Then adding all of this, the answer is 9.5. Let us now answer the mean. The mean is the summation of X times P of X. So that is 2.9. Variance is using the formula, the summation of X squared times P of X minus the mean squared. And that is equal to 9.5 minus 2.9 squared equals 1.09. Then to get the standard deviation, we will just get the square root of 1.09, and that is equal to 1.04. For our lesson, suppose that all possible sample size n are drawn from a population with mean mu and standard deviation sigma. Then the means obtained from all these possible samples will make up a sampling distribution of the sample means exhibiting the following properties. This is when variance is unknown or the population is finite. Number 1, the mean of the sample means is the same as the population mean. 2, the variance of the sampling distribution of the sample means is given by the formula sigma squared over small n times the quantity big N minus small n all over big N minus 1. For finite population, a finite population consists of a finite or fixed number of elements, where big N is the population size and small n is the sample size. 3. The standard deviation of the sampling distribution of the sample means is given by the formula sigma over the square root of n times the quantity square root of big N minus small n all over big N minus 1 for finite population, where the square root of big N minus small n all over big N minus 1 as the finite population correction factor. The correction factor is necessary if relatively large samples are taken from a small population, because the sample mean will more accurately estimate the population mean and there will be less error in the estimation. In general, when the population is large and the sample size is small, the correction factor is not used since it will be very close to 1. Computed standard deviation from the population may be different from the standard deviation for sampling distribution. This is because of the sampling error. The sampling error is influenced by two factors, the population variance and the sample size. Sampling error and sample size are inversely related. The smaller the sampling size, the greater the sampling error. Let us now discuss examples. Example 1. Random samples with size 4 are drawn from a population having the values 14, 19, 26, 20, 44, and 47. Find the mean and the standard error of the sample mean. Solution. Solving for the population mean, we add 14 plus 19 plus 26 plus 20 plus 44 plus 47 and divide it by 6. And that is equal to 28.33. Thus, the mean of the sample mean is equal to 28.33. To get the standard error, compute first the population standard deviation by getting the square root of 14 minus 28.33 squared plus 19 minus 28.33 squared plus 26 minus 28.33 squared plus 20 minus 28.33 squared plus 44 minus 28.33 squared plus 47 minus 28.33 squared all over 6. And that is equal to 12.19. Solving for the standard error, we will use the formula sigma over the square root of small n times the square root of big N minus small n all over big N minus 1. Substituting the values, 12.19 over the square root of 4 times the square root of 6 minus 4 all over 6 minus 1 equals 3.85. Example 2. Consider a group of n, big N is equal to 4 people with the following ages, 16, 18, 20, and 22. Consider samples of size small n is equal to 2 from the group. If sample mean is the average of the 2 people in a sample, find the mean and variance of the sampling distribution of the sample mean and compare these values to the mean and variance of the population. Solution. Compute the population mean. Mean is equal to summation of x over n. So, 16 plus 18 plus 20 plus 22 all over 4 equals 19. Then, using the mean, compute the variance of the population by completing this table. Okay. For x minus mean, we will subtract each value of x minus 19. 16 minus 19 is negative 3. 18 minus 19 is negative 1. 20 minus 19 is 1. 22 minus 19 is 3. Then, for the next column, we will square the answers here. This is x minus mean squared. So, negative 3 is 9. Negative 1 is 1. 1 squared is 1. 3 squared is 9. And then add all of this. The answer is 20. So the population variance is the summation here, which is 20 over the population size. So 20 divided by 4 is equal to 5. Next, determine the number of samples of size n is equal to 2. Use the formula for combination to find the number of samples. Big N, C, small n. Here, population size is 4 and sample size is 2. So 4C2 is equal to 6. There are 6 possible samples of size 2 that can be drawn. List all possible samples and their sample means. Let us now list down the possible samples. 1618, 1620, 1622, 1820, 1822, 2022. Then get the sample mean of each pair. 16 and 18 is 17, 16 and 20 is 18, 16 and 22 is 19, 18 and 20 is 19, 18 and 22 is 20, 20 and 22 is 21. Then construct the sampling distribution of the sample means. List down all the sample means from the previous table and its corresponding frequency. 17 is 1, 18 is 1, 19 is 2, 20 is 1, and 21 is 1. Total frequency of 6. Then the probability for each sample mean, 1 over 6, 1 over 6, 19 is 2 over 6 or 1/3, 20 is 1 over 6, and 21 is 1 over 6. So the total of the probability is 6 over 6 or 1. Follow these procedures. First, compute the mean of the sampling distribution of the sample means using the formula summation of sample mean times the probability of the sample mean. Multiply the mean by the corresponding probability and then add the results. Then compute the variance using the formula summation of sample mean times the probability of the sample mean minus mean of the sample mean squared. Let us now complete the table. X times P of X. 17 times 1, 6, 2.833. 18 times 1, 6 is 3. 19 times 1/3, 6.333. 20 times 1, 6, 3.333. 21 times 1, 6 is 3.5. Add all of this. The answer is 19. Next is to square the value of X, the sample mean. 17 squared is 289. 18 squared is 324. 19 squared is 361. 20 squared is 400. 21 squared is 441. Then after that, next column, multiply each x squared by p of x. 289 times 1, 6, 48.17. 324 times 1, 6, 54. 361 times 1/3, 120.33. 400 times 1, 6, 66.67. 441 times 1, 6, 73.5. Then add all of this. The answer is 362.67. So the mean is equal to 19. The variance is equal to 362.67 minus 19 squared equals 1.67. Therefore, the mean of the sample mean is 19 and variance of the sample mean is 1.67. We can observe that the mean of the sampling distribution of the sample means is equal to the mean of the population. Therefore, if a population has a mean mu, then the mean of the sampling distribution of the mean is also mu. Another method for computing variance is if the population is finite with mean mu and standard deviation sigma, use the correction factor. Using the formula sigma squared over n times the quantity big N minus small n all over big N minus 1. Substitute sigma is equal to 5 population size is 4, sample size is 2, equals 5 over 2 times the quantity, 4 minus 2 all over 4 minus 1. Simplifying, 5 over 2 times 2 over 3 equals 5 over 3 or 1.67. Example 3. A teacher gave a 10-point quiz to a small class of 5 students. The results of the quiz are 2, 5, 7, 8, and 10. Find population mean, variance, and standard deviation. Mean, variance, and standard deviation of the sampling distribution of the sample means. Solution. Solving for the population mean, we add 2 plus 5 plus 7 plus 8 plus 10 divided by 5. The answer is 6.4. Then for the variance, we get the square of 2 minus 6.4 plus 5 minus 6.4 squared plus 7 minus 6.4 squared plus 8 minus 6.4 squared plus 10 minus 6.4 squared all over 5. The answer is 7.44. And then solving for the standard deviation, we just get the square root of 7.44 equals 2.73. Then determine the number of samples of size n is equal to 2. Use the formula for combination to find the number of samples where population size is 5 and sample size is 2. So 5C2 is equal to 10. There are 10 possible samples of size 2 that can be drawn. List all possible samples and their sample means. So the samples are 2, 5, 2, 7, 2, 8, 2, 10, 5, 7, 5, 8, 5, 10, 7, 8, 7, 10, 8, 10. Then get the sample mean of each pair. 2 and 5, 3.5. 2 and 7, 4.5. 2 and 8, 5. 2 and 10, 6. 5 and 7, 6. 5 and 8, 6.5. 5 and 10, 7.5. 7 and 8, 7.5. 7 and 10, 8.5. 8 and 10, 9. Then construct the sampling distribution of the sample means. So these are the means that we got from the previous table. Corresponding frequency, 3.5 is 1, 4.5 is 1, 5 is 1, 6 is 2, 6.5 is 1, 7.5 is 2, 8.5 is 1, 9 is 1. Total frequency of 10. So the probability of each for 3.5 is 1 over 10, 4.5 is 1 over 10, 5 is 1 over 10, 6 is 2 over 10 or 1/5, 6.5 is 1/10, 7.5 is 2 over 10 or 1/5, 8.5 is 1 over 10, and 9 is 1 over 10. Total probability of 10 over 10 or 1. Then compute the mean, variance, and standard deviation of the sampling distribution of the sample means. Let us complete the table. X times P of X, 3.5 times 1 over 10, 0.35. 4.5 times 1 over 10, 0.45. 5 times 1 over 10 is 0.5. 6 times 1/5, 1.2. 6.5 times 1 over 10, 0.65. 7.5 times 1/5, 1.5. 8.5 times 1 over 10, 0.85. 9 times 1 over 10, 0.9. Then let us get the square of each x. Oh, so the total of x times p of x is 6.4. 3.5 squared is 12.25. 4.5 squared, 20.25. 5 squared is 25. 6 squared is 36. 6.5 squared, 42.25. 7.5 squared, 56.25. 8.5 squared, 72.25. And 9 squared is 81. Then multiply each x squared by p of x. 12.25 times 1 over 10 is 1.225. 20.25 times 1 over 10 is 2.025. 25 times 1 over 10 is 2.5. 36 times 1/5 is 7.2. 42.25 is times 1 over 10 is 4.225. 56.25 times 1/5, 11.25. 72.25 times 1 over 10 is 7.225. 81 times 1 over 10 is 8.1. Adding all of this, the answer is 43.75. So the mean is the sum of x times p of x, 6.4. The variance of the sample mean, 43.75 minus 6.4 squared equals 2.79. And the standard deviation of the sample mean is the square root of 2.79, which is 1.67. Okay? Using the correction factor, variance of the sample mean, using the formula sigma squared over the sample size times the quantity population size minus sample size all over population size minus 1. Let us substitute. Sigma is 2.73, big N is 5, small n is 2. So 2.73 squared over 2 times the quantity 5 minus 2 over 5 minus 1. 7.45 over 2 times 3/4 equals 2.79. And for the standard deviation of the sample mean, using the correction factor, the formula is sigma over square root of n times the square root of big N minus small n all over big N minus 1. Substitute the values. 2.73 over square root of 2 times the square root of 5 minus 2 all over 5 minus 1. That is equal to 2.73 over square root of 2 times the square root of 3/4 or 1.67. Okay, for our wrap up, do you still remember the formulas and concepts we used in the lesson? Okay. So the variance of the sampling distribution of the sample means is given by the formula sigma squared over small n times the quantity big N minus small n all over big N minus 1 for a finite population. The standard deviation of the sampling distribution of the sample means is given by the formula sigma over square root of n times the square root of big N minus small n all over big N minus 1 for a finite population, where the square root of big N minus small n all over big N minus 1 as the finite population correction factor. The number of samples of size m, small n, that can be drawn from a population of size n is given by big N C small n. And the probability distribution that describes the probability for each mean of all the samples with sample size n is called sampling distribution. Since we discussed about mean and variance, how do teachers deal with a class of 45 or more students? Dealing with large classes constitutes a real challenge to every teacher, if the aim is to give quality teaching and learning outcomes. With a large number of students in every class, it is difficult to assess and evaluate students' need and performance. One of the teaching strategies employed by a teacher with large number of students in a class is the cooperative learning approach. Break the students up into small groups and create a more manageable group. If I ask you, when your teachers give group work in this time of pandemic, how are you going to do your part as a leader or as a member? Remember that cooperative learning benefits both students with poor academic histories and top students in the class, as individual effort is required. If there is cooperation and unity in the group, there will be less errors in the output. It develops respect, teamwork, and engagement among the members. Okay, so I will now leave you with activities to work on and post-tests to check what you have learned today. Activity 1, Activity 2, and a post-test. To check your answers, refer to the key to correction. Here are the references for this lesson. That's all for today. Keep safe always, and God bless everyone.